Good afternoon. My name is Mauricio Alejandro Perez Gonzalez. My matricle number is 21175117, and my career is IMTC or mechatronic engineer. In this case, in this work, I'm going to explain the forces acting on a sail-powered motorboat. First, we have the weight of the boat or gravitational force. This acts vertically downward from the center of the mass of the boat. It is a force that the body exerts on a support point. In this case, is the sea. Its formula is weight equals m by g, where m is the mass of the boat and g is the acceleration due to gravity. Next one, we have the hydrostatic thrust or buoyant force. This is the force exerted by water equal to the weight of the displaced volume of water. It is explained by Archimedes' principle, which states that any body submerged in a fluid experiences an upward force equal to the weight of the displaced fluid. Its direction is opposite of the boat's weight. Therefore, it acts upward. The formula is force of water equals multiply density of water by V displaced by G, where V water is the density of water, V displaced is the submerged volume of the hull, and G is gravity. The third force is the thrust force from the engine. This comes from the thrust generated by the engine, which produces in two directions. First, the propulsion force caused by the water expelled by the propeller, and the second, the movement of the boat, which is opposite to the direction of the expelled water. The formula is force of the engine equals multiply m by v. M is the mass of the water expelled by the propeller per unit of time, and v is the speed of the water that jets relative to the boat. Next one, we have the wind force on the sails or aerodynamic force. This is divided in two components. Number one is the lift. This is the aerodynamic force acting on an object moving through air, which gives it a force of lift. It is perpendicular to the apparent one. This is basically the force that goes in the direction of the boat moving. Next, we have the drag. This is a force that opposes the motion of an object through air. It's caused by the collision of the object with air molecules and is directly proportional to the object's velocity. It is opposite to the apparent wind. So if the apparent wind in the lift is this direction, then the drag is going to be the opposite direction. Next, we have the formulas. Here's the formula of the lift is force of the lift equals 1/2 by P of air by A by CL by B by the square rotation of V apparent. In this case, V apparent is the apparent wind, CL is the lift coefficient, A is the area of the sail, and P air is the density of air. Now for the drag, the formula is pretty similar. Force of drag equals 1/2 by P of air by A by CD by a square of V apparent. Like I explained, V apparent is the apparent wind, A is the sail area, P of air is the air density, and in this case, CD is the drag coefficient. The next one is the water drag force or hydrodynamic resistance. This is the force that opposes the motion of an object in water. It is always opposite to the object's movement, and its magnitude increases with the speed of the object. It also depends on the size of the bow and the turbulence present at the moment. The formula is force of drag equals multiplied of 1/2 by P of water by A of bow by CD by a square of V. P of water is the water density, A of bow is the bow area, CD is the drag coefficient, and V is the boat speed. The last one is, wait, it's not the last one. It's kind of the last one because both are similar forces, but I will explain that later. It's the viscous bladder friction force. Part of the hydrodynamic resistance, this is a force that opposes the motion of an object through water, caused by the water's internal resistance of flow. So this force is a part of the water drag force. So technically, when we count the water drag force, we are also counting this force. Formula is force of friction equals multiplying of 1/2 by P of water by C by CF by P square of V. P water is the density of water, S is the submerged surface of the area of the hull, CF is the friction coefficient, and V is the bow speed that is relative to the water. Now, finally, we have the last force, the sheet tension. This is the force required to keep the sail in its place using the sheet. The approximate formula for this one is tension of sheet equals multiply of F of sail by D, and this divided by L. F of sail is the total aerodynamic force of the sail. D is the vertical distance from the sail center to the effort of the boom, and L is the horizontal distance from the sheet point to the mast. Now that we have all these forces, these are all the forces that allows the boat to move and explains how the boat moves. Now, what are the skills that we developed through this project? First is the understanding of physics concepts. A solid understanding was demonstrated of fundamental physics laws such as the law of gravity, Archimedes' principles, and the concept of aerodynamic and hydrodynamic forces, along with the application of physics formula to describe these forces. Thanks to this, we were able to correctly identify which forces act on the boat and what factors influence the calculation of these forces. Next skill is the analysis and modeling of physical systems. All relevant forces acting on a sail-powered motorboat were identified and analyzed. With this information, a conceptual model was built to understand how the different forces interact and affect the boat's behavior. Through this knowledge, we determined the direction of these forces to correctly draw the direction arrows from each one involved. Next is the mathematical reasoning. Appropriate mathematical and physical expressions were used to calculate forces. At the same time, we gained a true understanding of how these formulas work and how each variable magnitude affects the final result. Next is the critical thinking. We evaluated how different variables such as density, speed, aerodynamics, and coefficients, etc., influence the boat's behavior. Opposing and complementary forces were distinguished, demonstrating a critical understanding of the force equilibrium. The last one is our research ability. We exercised our research skills by formulating research questions, gathering and analyzing data, and clearly and concisely interpreting and communicating the results of our investigation. Now, what did I think about this research project? Did I thought this was appropriate for the lab or not? Well, in my opinion, the assignment given to us this time was extremely interesting and appropriate for the goals of the laboratory work. The purpose of laboratory session is to use practical activities and research to solve a given problem. By using prior knowledge, newly applied concepts, and through research, we were able to solve these problems presented to us. In this case, which was to identify the forces acting on a sail-powered motorboat, we used knowledge acquired in the lab, such as Archimedes' principles, but we also used prior knowledge such as weight and engine forces. And through research, we gained new concepts, new information, and we discovered other concepts like water friction. Completing this project required all of the above, which led us to develop the previously mentioned competence. For this reason, I believe this project was perfect for the kind of knowledge the lab aims to promote. So in general, I think I'm pretty happy with how this project went and all the things that I learned from it. Especially this part of the English conversation, I think is a pretty interesting concept, and I've never seen any professor doing this type of work. So I have to admire the effort that the teacher is putting in this. So thanks to you for hearing this exercise, and have a nice day.